They want us to give them a picture, an illustration, and definition. So let's start with the improper fraction. If someone asked you, what is an improper fraction? How could you explain it to them? If somebody was brand new to our class, they had never seen this, and they asked you, what is an improper fraction? How could we explain it to them? Bella, make sure we're focused on the math, okay? Kylie, how would you explain it to them? They asked you, Kylie, what's an improper fraction? How do you think you could explain it to them? I like your description so far. Let's use it for the illustration. Okay. But I like how specific you were. Let's use that for the illustration. You said there were 3 whole fractions, right? Okay, so I'm going to draw 3 circles. 1, 2, 3. And you said there were 6 pieces on all of them, right, Kylie? Okay, so I'm going to cut them into 6 pieces. To cut a circle into 6 pieces, all I'm going to do is draw a line horizontally and then make a letter X. That'll give me 6 pieces. And then how many pieces did you say were shaded in? Okay, that they were all shaded in. Okay. I'm going to shade in all of the pieces here. So I think that's a pretty good illustration to go. The only thing that I'm wondering is how do I finish the definition? Because I like the way you started it. An improper fraction is like hold on. Not a faction, a fraction. Like a fraction, except what? What makes an improper fraction different from a regular fraction? Kylie gave us. I think that's perfect. It's like a fraction, except. Oh, hold on. I tried to mix up my words. Except the denominator is smaller than the numerator. So it's almost like the reverse, or it's almost like it's backwards compared to a regular fraction. Normally, your denominator is the bigger number there, but in an improper fraction, it's the opposite. The improper fraction has a smaller denominator and a bigger numerator. Like here, if I were to write an improper fraction that would match my model here, I'd have 6 as my denominator because each of these circles is cut into 6 pieces. I don't know why, maybe because it's getting closer to lunch, it just looks like pizza to me. So I'm just going to call it pizza. Each of these pizzas is cut into 6 pieces. And if I count all of the pieces that are shaded in, would get 6, 12, 18. So our fraction would be 18 out of, see that our denominator is smaller than the new. And they also asked me about a mixed number though. I think we've got a good picture and a good definition for an improper fraction. What could I draw or what could I write to tell people what a mixed number is? What is a drawing or what is a definition, a sentence I could write that would tell them what a mixed number is? Bailey. Oh, hold on, baby. Hold on. I was asking Bailey. But if Bailey needs help, I'll call on you. Okay? Sure. So we're looking for mixed number now. Can you give me either a sentence that would help explain it, or you could tell me what I could draw to help explain what a mixed number is? Okay.
Each of them are into fifths.
Okay. And then what should I do? Okay, so I'm going to color 3 whole circles.
And to the last one.
And then 2 pieces. Okay. I agree with you. I think that's a pretty good picture to draw for a mixed number. All right. And then, Kaylee, you wanted to help? Kaylee, how could I explain to somebody? Like if someone who had never been to our class, they were brand new and they asked you, Kaylee, what's a mixed number? What would you tell them? You can use this picture that we drew here to help you out. So it's like when there's what? It does have a bigger denominator and a smaller numerator, but we could also say that's a regular fraction. So who can help me explain what makes a mixed number different from a regular fraction? What does a mixed number have that a regular fraction doesn't? That I won't find on a regular fraction. So I'll still find numerators, I'll still find denominators. The denominator will be bigger. So what would be different? Noah, what would be different between a mixed number and a fraction?
X
Okay.
and then no numbers add more.
Add more what?
Hard to explain.
That's okay.
Pieces.
Okay, more pieces. All right. There's a word that Kaylee was was almost about to use, and I think it'll work great here. So this, if I was gonna write this as a fraction or as a whole number, a mixed number, how would I write this as a mixed number, Noah? Okay, so how would I write this if this was my model? How would I write this as a mixed number? Do you need some help, Noah? Okay. Who can help Noah out? How would I write this model as a mixed number? Violet?
Oh, well, 2 as
Okay.
into
Okay.
and then a 1. I mean a 3.
A 3. Why a 3? Why not a 1?
Figure shape.
Because there are 3 figures shaded. Okay. So this would be my mixed number. 3 and 2 out of 5. So Haley told us that there's going to be a denominator, there's going to be a numerator. Your denominator is bigger, but what does this have that any other fraction wouldn't? What makes this different from just a regular fraction? Kylie? So what makes a mixed number different is that it has a whole number and a fraction. And I think that's what Noah was trying to tell us, that it's got more pieces. It's got more than it needs to make 1. In this case, we made 3. So our definition could be a mixed number is a fraction that also has a whole number. So these numbers that I write next to my fractions and I write them really big, Those are whole numbers. Because like Violet said, those are whole models or whole things that they would have. In this case, 3 whole models and then 2 more pieces. A mixed number is a fraction that also has a whole number. Okay. And we have 2 more questions here. Write an improper fraction for 7/3. Okay. So they want an improper fraction. 7/3. Got it. Then write the improper fraction as a mixed number. So they want us to change the improper fraction into a mixed number. The other day I had shown you a few different ways to do this. Jadine, do you remember one of the ways?
Add.
Not adding, but it's a different operation.
Addition?
No, adding is the same thing as addition. What's the opposite? What would be the opposite of adding?
Subtracting.
Subtracting. So I could use subtraction.
Mr. I have another question.
Oh, okay.
You know, in the back, this one too?
With this one, we can't. The multiplication and the adding only works if you have a mixed number. But we have an improper fraction. We're going the other way. So we can use subtraction though. So let's start with 7. It's our numerator. And I'm going to be subtracting my denominator. 7 minus 3. What's 7 minus 3? Alexa? 4. Okay. Alexa, if I have 4, can I still subtract another 3? All right, let's do it again then. 4 minus 3. What would that leave me? 1. Okay. Alexa, if I have 1, can I subtract another 3? No. Okay. How many times could I take away 3? On this one, how many times was I able to subtract 3? 2 times. 1, 2. So my whole number is 2. Like I said earlier, my denominator does not change. But what's my numerator, Alexa? What's the new numerator going to be? 1. It's whatever I had left over. 2 and 1 out of 3. Now this wasn't the only way that I had shown you to do this. There was another one. The other one was using our number songs. Right? Again, my 3's the important number here. So I'm going to write my 3's number song until I either get 7 or I go too far. 3, 6, 9. Oh, well, that wasn't very long. 9 is too much. I could count by 3's 2 times. There's my whole number. My denominator stays the same. And all I have to do to figure out my numerator is take the biggest number I got to, 6, and subtract it from 7. 7 minus 6. What is 7 minus 6? Christopher? 7 minus 6 is what? One. Hey, look at that. 1. And there's my numerator. There was one last way I had shown you all to do this. Like I told you, this way, honestly, I don't like it. Because for this problem, it wouldn't be too bad. But for problems with really big numerators, it's going to take a lot of space and a lot of time. But I'll show it anyway. I'm going to draw 7 dots because that's my numerator. 1, 2, 3, 4, 5, 6, 7. I'm going to put them in groups of 3. 1, 2, 3, 1 group. 1, 2, 3, 2 groups. 1. That's it. 1, 2 groups. And how many pieces did I have left? I had 1. And my denominator stays the same. Whichever method you want to use, all of them work, all of them give you the same answer. Again, the only one I would tell you not to, if you can, is this one. Even though that method works, it takes the most space and it takes the most time, depending on what the ones that will work pretty much just as fast and they'll use about the same amount of space no matter what size your numerator is, be these two. So I would pick either the subtraction or I'd use your number songs. But both of them will work. They will both give you that same answer. So you can use whichever one. Now, Jadine, you asked about the multiplication and addition one. You can only do that multiplication and addition if you start with the mixed number. Okay? So you have to start with the mixed number to use that multiplication and addition one. If you start with the improper fraction, you have to use one of these.
Like the two.
Yeah, so if you started with this, then you could use the addition and multiplication to change it to this. See? Because if you did that, 3 times 2 is what, Jadine?
Say it again, sorry.
Okay. What's 2 or what's 3 times 2? Plus 1? 7 out of 3. Okay, last one. Use an illustration or a drawing to connect the meaning of the improper fraction and the mixed number. All they want us to do is show them that the improper fraction and the mixed number are the same thing. So to do that, all we have to do is draw a model for it. We know we need 2 whole models plus 1 more. This time I'm going to make them rectangles. 1 model, 2 models, 3 models. My denominator is 3. So I need each one cut into 3 pieces. 1, 2, 3. 1, 2, 3. 1, 2, 3. I'm going to color in 7 of these pieces. 1, 2, 3, 4, 5, 6, 7. Then, just to show them that they are the same, on the top, I'm going to show them the improper fraction. On the bottom, I'm going to show them the mixed number. I'm going to count all of these boxes that we colored in. 1, 2, 3, 4, 5, 6, 7. 7 boxes that we colored in. On the bottom, I'm going to show them the mixed number. So we shaded in 1 whole model. We shaded in 2 whole models. And then on the last model, we didn't shade all of it in. We only shaded in 1 out of 3. So we use the same model. We could write it either as an improper fraction or as a mixed number.